All right, today you're going to be talking about and working with tangents. And a tangent screen's frozen. Here, let me thaw it out. Get it? Thaw it out. Tangent is a line or segment that intersects a circle in exactly one place. Touches a circle in exactly one place. So if you got a circle and you have a line or a segment that just one place. L would be your tangent. Point A right here would be called point of tangency. And we're going to say the angle formed by a radius and a tangent is always 90 degrees. The angle formed by a radius and a tangent is always 90 degrees. So if we go back to this circle, put a center in the circle, and connect that center to this point of tangency, this angle is 90 degrees. So you'll be using that concept today to be finding side lengths of lines and segments that are tangent to and intersecting circles. Now, if you're asked to determine whether KL is tangent to circle J, determine whether KL is tangent to circle J. And you're given this picture here. There's circle J. Here's a radius. Here's what appears to be a tangent. And if you're given these lengths here, let's say that this is 9 and this is 15. And this piece right here is 8. All right, you're kind of doing the converse of the, not the converse of the Pythagorean theorem, but you're going to use the Pythagorean theorem to see if a leg squared plus a leg squared is equal to a hypotenuse squared in this triangle. And if that's true, then this angle is 90 degrees and this is a right triangle. All right? So they're giving you this line KL and they're making it appear as though it's tangent to the circle, but they're asking you to basically prove that it's tangent. So before you do anything, do you see this J to L that's 8, that radius that's 8? Well, J to the edge of the circle right here is also 8. So don't forget about that. That makes this entire side of this triangle equal to 17. So what you're trying to determine now, you're trying to figure out is 15 squared plus 8 squared equal to 17 squared. Because if it is, then this is a right triangle, and this angle down here is 90 degrees, and KL is tangent. If 15 squared plus 8 squared does not equal 17 squared, then that is not a right triangle, and KL is not tangent to the circle. That makes sense? So in your calculator, you push 15x squared plus 8x squared, and you get 289. And you do 17x squared, and you get 289. So these two are equal. So is it? Yes, it is. All right. So determine whether KL is tangent to circle J. Yes, it is, because a squared plus b squared equals c squared. This is a right angle, and you've got a radius and a tangent that intersect at 90. Make sense to everybody? Very good. Very good. So take this now, and let's do another circle. My circles are not very good. I apologize. In years past, they have been excellent, but something with this COVID has my circle drawing ability all distorted. So we got an 8 and a 6 and a 12. H, G, and F. H, G, and F is HG tangent to circle F. All right, so again, don't forget about this 6 right here. This 6 that's at GF is also 6 right here. So this hypotenuse is 18. So we're trying to find out if 8 squared plus 6 squared equals 18 squared. And I know that 8 squared plus 6 squared, that's 100. And 18 squared, that's 18 squared, it's not 100. I know that. So those two are not equal to each other. So is HG tangent to circle F? That's a big no. It appears to be, but it's not. That angle down there is not a 90-degree angle. Everything okay? Yeah. Very good. Questions? Alrighty then. Let's find the value of x here. We're going to say lines, segments that appear to be tangent R tangent. So now what they're telling you is if the line looks like it's tangent, it is, and it forms a 90-degree angle. So we got this circle. That's a little better, but not much. Here. All right, GJH. We got XX, 8 and 12. So now look, this side, this hypotenuse of this right triangle is equal to x plus 8. So this kind of changes things. You haven't done this in a while. You haven't had to square a binomial in a while. So what we got here is you're told that if it appears to be tangent, it's tangent. So that means this is 90 degrees. So we got to take x squared plus 12 squared and make it equal to x plus 8 squared. We got to solve for x. So on this left-hand side, x squared plus 12 squared equals. Now, if you remember from Algebra 1, x plus 8 squared, that's the same as x plus 8 times x plus 8. And you got to do the distributive property twice here. So you got x times x, which is x squared. You got x times 8, which is positive 8x. You've got an 8 times an x, which is another positive 8x. And you've got an 8 times 8, which is positive 64. When you combine your like terms, you get x squared plus 16x plus 64. So on the right side of this equation, you got x squared plus 16x plus 64. So when you've got an x squared, a 1x squared on both sides of the equal sign, you can cancel it out. It's like subtracting x squared from both sides. It would go away. And then you can subtract 64 from each side. So 12 squared minus 64, that equals 80. And this 16x falls down. And you can divide both sides by 16. So 5 is equal to x. You guys okay with that? Y'all remember how to square a binomial? Anybody need to see another example of squaring a binomial? Anybody remember the shortcut for squaring a binomial? We just did x plus 8 squared, right? X plus 8 squared. X plus 8 squared was equal to this. Look, x squared equals x squared. 8 squared equals this 64. And 2 times 8 times x is 16. So watch. What about x plus 7 squared? What would the first term be? And what would the last term be? Right? And in the middle, 2 times 7 times x. Kind of a shortcut. If you had x plus 6 squared, x squared plus what? Plus, good. Very good. Let's do a few more. Just make sure that you're on the, because it saves you a lot of time if you don't have to do the distributive property twice. So here we got x squared plus what? 9. Good. And let's do one more. First term. Good. Middle term. Last term. Just 4. Okay. You're going to have an x squared at the beginning. You're going to have a regular number at the end. And in the middle, you're going to have a number times x. And that number times x in the middle is the exponent times that number. 2 times 6, 12. 2 times 2, 4. 2 times 3, 6. Y'all see the pattern? Okay, very good. Now, remember, there's if this x isn't here and they only show you this one, right? If they only show you this x from G to the circle and they leave this blank, both of these distances, G to the edge of the circle and G to J, they're both radiuses, right? They both go from the center to the edge, so they're the same as each other. So sometimes you have to fill that in. And sometimes they give you a value, and sometimes they put a variable there. All right, second part of your assignment today. Here's the rule. If two segments from the same endpoint are tangent to a circle, then they are congruent to each other. If two segments from the same endpoint are tangent to a circle, then they are congruent to each other. So that means if you have a circle, and now out here we've got a point A, and from this point we have a segment that's tangent to a circle. And from the same endpoint A, we have another segment that's tangent to the circle. If AB is tangent to circle D and AC is tangent to circle D, then they are congruent to each other. That's the rule. Very simple rule. If the two segments are tangent to the same circle and they start at the same place, they both start at point A, they're both tangent to D, then they're equal to each other. The problems you'll see today will look like 2x plus 9. And AC is 3x plus 6. And you have to solve for x. All right? So if those expressions represent those tangents, then you write a formula, or not a formula, but you write an equation. So you say 2x plus 9 is equal to 3x plus 6. And you solve for x. So you can subtract 2x from each side. And 9 is going to equal x plus 6. And then you can subtract 6. And 3 is equal to x. If they asked you to find the length of each tangent, well, then you substitute. 3 times 3 plus 6 is 15. And if they're congruent and your math was correct, then the other will be 15 as well. And that's 2 times 3 is 6 plus 9, that's 15. So the math is correct. All right, let's do one more of these. Let's take this. Let's say here, perimeter equals 18. Perimeter of RSTU equals 18. Find x. Let's see. Oh, this drawing is going to be tough for me. So let me try to go here. Oh. Not acceptable. One more time. All right, so we're going to draw a quadrilateral around this thing. Hopefully. There's the tangent. Oh boy. What you've got is a circle. Oh man, this is bad. You'll get the idea. I'll blow it up some. All right, what we got here. There's T U R S. We've got an X right here and an X right there. A 3 and another 3. All right, so watch. See point T right here? Point T has 2 tangents coming out of it, right? If one of them is X, what's the other one? Good, X. Because they're both tangent to a circle, same endpoint. So point U has 2 tangents coming out of it. They're both tangent to the same circle. So if one of these tangents is X, what's the other one? Good. If this down here coming out of R, if this one tangent is 3, what's this one? Coming out of S, one tangent is 3, so the other tangent is 3. Well, wouldn't the perimeter be equal to all of these segments added together? you've got 1, 2, 3, you got 4 x's plus 1, 2, 3, 4 3's. 4x plus 12 is equal to the perimeter that they gave you here. And this perimeter was 18. Everybody see that setup? All these segments, these 1, 2, 3, 4, 5, 6, 7, 8 tangents added together would give you the perimeter of this quadrilateral. So if you know the perimeter of the quadrilateral, you can take all these pieces as a sum and set them equal to each other. So if you subtract 12 right here, you get 4x equals 6. And then you can divide both sides by 4, and x would equal 1.5. So there's your value of x for a perimeter of 18. Make sense to everybody? Simple enough? Okay, your practice for today. Page 736 and 737. Let's see, we got 4 through 16. Oh, it's 4 through 27. 4 through 27. All right. If there's work required, which there is on almost all of these, okay, then I want you to show your work. You in-classers, you are going to put it in the basket. E-learners, you are emailing a picture of your work. All right. So there it is for today, your assignment. If you're an e-learner, you're excused at this time to go do your assignment. It needs to be emailed to me at the end of the period. No quiz tomorrow. No quiz tomorrow. Tomorrow you're going to be map testing. Did you guys already map test in here once? Yeah, we're going to do another one tomorrow. So, e-learners, you're excused. Go do your work. E-learners, there will be no Zoom meeting tomorrow. E-learners, no Zoom meeting tomorrow. We're going to be map testing here at school if you want to come into school and map test. If you don't, you don't. I guess they'll try to schedule you a makeup or you won't take it. I don't know how it's working at this particular time. So you're excused for today, and there's no Zoom meeting tomorrow, and there's no quiz this week.